Hello and welcome back to another easy interview. By now you probably know the drill. We're trying to practice speaking and communicating while we implement a solution to a LeetCode problem. Easy problems help with that because you spend less time trying to crack like the coding problem, and you get more time to focus on your communication, explaining trade-offs, explaining how and why you're implementing things, etc., etc. So yeah, so we're going to take a look at LeetCode 1047, remove all adjacent duplicates in a string. I have solved this before, but that's quite some time ago. So this is the first time I'm looking at this again, and hopefully I will succeed. So let's dive into it. So you're given a string S consisting of lowercase English letters. A duplicate removal consists of choosing two adjacent and equal letters and removing them. I guess maybe both of them. We repeatedly make duplicate removals on S until we no longer can. Return the final string after such duplicate removals have been made. It can be proven that the answer is unique. Okay, great. What are the constraints? So our string has a length of at least 1. We don't have an empty string. And it consists of lowercase English letters only. For runtime analysis and space, we're going to ignore the fact that the string has a fixed max size. Otherwise, everything would be constant space and constant time automatically. But for interviews, we want to be able to do an analysis of our asymptotic space and time complexity. So yes, example 1, let's see. So we have a string ABBA CA, and the output is CA. So let's do the removal. So if we just remove BB, the first duplicate, that will give us AACA. And if we then remove the AA, that will give us CA as a result. Okay. Now, the fact that the answer is unique, that tells me that the order of the removal doesn't matter, I guess. Yeah, that's what that tells me. So we probably don't have to worry about the order in which we have to remove things. So let's look at the second string. So we would remove the two X here. We would then remove the two Z's, and we would be left with two unique, well, with the A and the Y. So the first idea would be just brute force. We just brute force it, and that means we iterate through the entire string in linear time. And while we do so, we spot duplicates and we remove them. So we would break up the string into two parts. And let me think. And we could, save it as a new string and then start from the beginning. Or we could check if the two parts, end and start with the same character as well. Then we could continue to chop away from those two strings. And if we can't, then we could maybe just continue with our linear traversal through the string. Now the challenge with removing characters from the middle of the string is that every time you do that, you create a new string. So removing a character is an O of n operation, technically speaking. So we would have a linear O of n to iterate through all of the characters, and every removal is another O of n. So potentially we have an O of n squared complexity. Right? If we have, we need to iterate over n characters, and if we do n removals, that's n times m, that's O of n squared time. And also O of n space, because we need to store the new string somewhere. So yeah, I would just implement this, and maybe we will find a more efficient way of doing this after. So time and of n space. And it's always good to be able to explain why creating a new string is not constant space or constant time. It also might depend on your programming language. So you want to look it up, if removing characters from string is a linear time thing or not. I would expect that it usually is. But anyway, so what we do is we have our for I in range length of S. Right? And then, well, we could start at 1 right away. So we know that the previous one is S is position I minus 1. The current one is position Si. If the previous one is the same as the current one, then we know we can remove that, right? Yes, that is when we know we can remove that. And if we make a new string, we would have to say S is now the previous string. So that's up until I minus 1 plus the string from I plus 1. Yes, and the beginning is inclusive and the end of the prefix is exclusive. So I is the last character and I minus 1 is the character before that. Right. And but if we form a new string, we also need to, I think, break out of this loop. And we have to, well, we have to keep doing this until we don't find any more duplicates, duplicate characters. So while keep looping. Let me see. Well, yeah, we need a flag, right? The flag needs to tell us whether we actually did a replacement in the pass or not. Because if we didn't, then well, if we didn't make a replacement, then we're done, right? So I will just say done is false to ensure that we enter the while loop, while not done. And here we would say done is false. We just made a replacement. But when we before we enter the for loop, we say, okay, I think we should be done. And only when we don't find a repeating character here, done will be changed back to false. Right. So and we need to output something, right? The remaining string, return S. So that's what we will do. Let's see if that works. Error, index out of range. Ah, I see. But why? I minus 1 and I plus 1. Oh, I have to do it like this, I think. Yes, I forgot the colon. There you go. So that works. I'm gonna submit it to see how well that works. So this is taking quite some time. So this could be a time limit exceeded error, simply because we're building so many different strings. Yeah, there you go. So that's not a great thing. Well, what can we improve? I believe that this solution is correct, but just LeetCode won't accept because it's running too slow. So how can we bring down this time complexity? Well, something that we could do is we could, I think we could turn this into a linear time algorithm if we, instead of a string, converted our string to an array. Because in the array, we can add and remove elements, at least from the end of the array, in constant time. So what we would probably have is we would have an array to which we will append, and we will have an array from which we remove the next character. So I'm thinking that if we have this string, and we'll have two arrays. And two arrays. And the first array would be prefix. That's the prefix of our string. And we'll have a postfix, that's the tail of the string. So for example, and we will start with the postfix containing all of the characters of the string, but in reversed order, because we can remove elements from the end of an array in constant time. Right? We can just do an array.pop that removes the last element. So if we put into this all of the characters, and then we just reverse the array, this would give us an array that contains, well, exactly this, but in reverse order. would contain A, C, A, B, B, and A. So that would be in here. And the other one is empty. So now what we will do is we will just, while we have any characters that we still need to consume, we're going to, well, just pop that character out. Is postfix.pop. So we're popping the last element from the array, but in reality, it's of course the first character from our string. And now we say, well, if we have anything in prefix, then what we will do is we'll check if the element in the prefix is the new character that we just got. So yeah, if prefix, and at the tail of prefix we have the character C. In that case, we need to pop that character from our prefix, because now the character C from the postfix and from the prefix, they annihilate each other, and so we just remove it. If that is not the case, that means we don't have any duplicate characters. What we'll do is we'll just remove, we'll just add the character that we just removed from the postfix to the prefix. So, and then in the end, we will have a prefix and an empty postfix, and all we need to do then is turn that back into a string. And there's nothing easier than to do that. In Python, you just join all the array elements together into a new string, like so. And yes, so I think that should work just fine. Let me just beautify this a little bit, at least to my aesthetic. Perception. And yes. Okay, I think that's it. Let's walk through an example. We'll start with this thing. We'll put that into our array. So C, A, B, B, A, that's our postfix. And what we'll do then is we will add, well, we will pop the last element from our postfix into our prefix. So our prefix will contain A. We pop that out. Next iteration of the while loop, we pop out the B. Now we suddenly have the case where the tail of prefix and the tail of postfix are the same. So boom, they annihilate. And now we could annihilate even further. So interesting. So yes, so what we'll do then is we will go into the next iteration of the while loop. We pop out the A. We determine, oh, A is the same as in our prefix, so they annihilate. Next, we pop out the C from the postfix and put it into the prefix. And then we finally pop out the A and append it here. So now we have CA. And incidentally, the prefix characters are already in the right order. So we can return them that way. Nice. I'm just going to run the test, see if that works. And I made an error. So prefix, let's see. Prefix. Why is that? Sequence you expected, a string instant found a list. Well, prefix append. That's a weird one. Did I make an error here? So this is a list, right? Oh, maybe because I initialized the postfix in the wrong way, and so that a list actually ended up in the prefix. Output AB, but we want CA. All right, so let's see here. Maybe I have to do this like this. Postfix reverse. Oh, that's still the same. So that is a weird one. So, well, let's see. So we fixed the error of where it was complaining that elements in the prefix were not strings. So we fixed that. Now we need to make sure that we reverse the postfix. So why don't we do that? So this should also give us a list if we do that. String attribute, okay, pop. Okay, so so that actually doesn't give us a list, but it just reverses the elements. Yeah, so those are some Python fundamentals that I need to be practicing. And this is part of why I'm doing this. So just to check, I'm going to see what is inside S and inside the postfix when we start. And print postfix. Right. So S is the prefix, and then the postfix is ABBACA. So that is correct, right? Cool. So that logic is correct. Oh, this is the error. We're looking at the first element in the prefix and not the last one. Okay, so that is that was the error, and yeah, I should have seen it. I didn't. Well, maybe next time. Okay, cool. So that works, and I'm just going to experiment with this. If I do list reverse, can I do this? Just want to know. This has nothing to do with the problem. I just want to know. No, reverse will reverse this thing in place, I guess. So we have to do it like this if we want to use that function reverse. Yeah, okay. Does Python also have a reverse method on a string? I wonder. Checking. No, it doesn't have an attribute reverse. Maybe like that. I don't know. Well. All right, let's just keep it like this. And I have to put this on my notes to kind of review exactly what operations I can perform on strings with reversing them and on lists to reverse them. I know this should work. Yeah, this reverses the string and we create a list from it. So let's just go with this one since it removes one more line. And yes, so just to recap, we iterate over all of the elements exactly once, because at each step we pop one of the characters from the postfix that contains all of the characters. We do the comparison, and well, if the tail of prefix and the head of the postfix are the same, they annihilate each other, and so it goes. So let's do the final submission. Boom. Okay, cool. So that is that. Yeah, I hope you enjoyed this video, and slight detours. That's all part of practicing. And yeah, happy coding, and I hope you enjoy implementing those two yourself as well.